issues in the past couple of months, a lot of those big organizations that have been hit over the past year or so, and you've probably come to realize that a lot of them follow a very similar pattern. We're going to first start by the attackers getting in. They need to get their foothold on the network somehow. So whether it be through some sort of phishing attempt, a malware injection, maybe even just a simple brute force attack, they need to get that network foothold, and that's that first initial intrusion phase. Once they're in, they're going to start to do some more internal reconnaissance. They're going to learn your systems. They're going to learn your accounts, and they're going to learn exactly where they are within your networks. And that's going to start to allow them to move laterally around the network, pivot from box to box, start compromising different accounts, to escalate those privileges as well. Because there's a reason why those attackers are there. More often than not, there's some sort of data that they're after. And eventually they're going to escalate their privileges enough that they'll be able to access that data. And then there's really just one step left: data exfiltration. They want to take that data out of the network and get it into their own hands. Now, because of this, I always like to bring up the Varonis cyber kill chain, and I'm sure this probably looks familiar to a lot of you guys, similar to some of those other security frameworks, things like the Lockheed Martin kill chain or some of the other kind of broader frameworks out there. The reason to bring it up today is because we have out-of-the-box threat models that map to every single stage of this kill chain. And you're going to see some of those threat models today. So whether we're looking at events in the reconnaissance or the intrusion phases, the lateral movement or the privilege escalation phases, all the way up until the point when that data is touched and taken out of the network, we have these predefined threat models. And really the great thing is you just have to turn them on. So enough about Varonis for now. Let's get to our attack scenario a bit. So this is our insider threat scenario that we'll go through. We're not so much worried about the intrusion failure. We're already on the inside, but we're going to start by doing some basic reconnaissance internally. We're going to first start by harvesting some Kerberos tickets through their SN. So a little bit of identify service accounts out there, take those Kerberos tickets. We're going to put you the service accounts, also the domain admins group. It's going to be how we start to escalate our privilege a bit. We use John the Ripper to actually crack a password hash and brute force a privileged service account, compromise that account, get that set of credentials. Once we have a set of credentials, we'll actually use it to access some data within one of our file shares, specifically the finance directory. We're looking to get some sort of insider financial information. And once we do, we're going to download the data. We'll locally on our end user workstation. We're going to exfiltrate it out of the network using a very similar method. So I know that was a lot up front pretty quickly. We're going to dive right into the attack right now. But before we get too far into it, just wanted to see, were there any questions out there on anything that I've done so far? And just feel free to jump in at any point.
Yeah, we've got a couple of questions. This is an insider threat attack. Correct, yeah, insider threat attack. Yeah, Ryan.
Could be someone with access to the network. Yes.
An insider threat can also be an outsider that has sent you a phishing email and has gotten your credentials and posting as an insider within the company. Right, that's what I'm saying.
Some of them are also like, I'm sure you guys have heard of Mimikatz. Like all these are included. These are stuff that you can Google, download very quickly. Probably don't Google it while you're at work. But you know, this is stuff that yeah. But it's also something that like 13-year-olds are out there doing this and getting into people's information. So it's stuff that's readily available if you do your research. It's very easy, and Ryan will show you kind of how easy it is to go and run some of these queries.
Ryan, we got one more question.
Oh, sure.
You mentioned basically staff law. Is there an agent that sits on these workstations that will capture those calls?
So everything we're doing is going to be on storage. We're not monitoring any of the endpoints. So for Windows filers, we do deploy an agent. It's a filter that sits on top of the kernel, catches everything that goes down. Windows native auditing is very resource intensive, so we try to stay away from that. For directory services, that's all stuff that's being recorded on the domain controller already. DNS logs we're forwarding. Sys logs are coming off of your different VPNs and web proxies. Stuff like enterprise storage, NetApps, Isilons, we're using Common Event Enabler to collect those events. And then the file crawls are being done from a server in your infrastructure. It's a collector, we call it. It goes out into the file walk, identifies where the data is, classifies it as local scanning, identifies the permissions, and so on.
Is
zero business impact is really what we want to preach. The Windows filer, for instance, is 1% CPU usage. Service Watchdog runs beside it. Make sure it doesn't go over that. If it does, it kills it. As far as the NetApp and Isilon, as long as the storage specs are up, there's plenty of extra room for it to record the events. You're not going to see anything there. We say it's typically like 3 users accessing the file system at all times. And then it's all software-based. So this is running on typically 3 to 4 virtual machines within your environment, and just, maybe 8 cores, 32 gigabyte of memory for each of the servers. We say 500 megabytes of storage space that we're storing all these events for every 500 users per month. And so it does add up because we're creating this audit trail over time. We will archive stuff after a year, so we'll zip it up and compress it. You can always rehydrate stuff. So if there's something, request for information from more than a year ago, you can go back and pull that information back in. 500 megabytes per 500 users per month. 500 megabytes per 500 users per month. So, yeah. I'm sorry. I'll tell you something. I got to wrap my head around it sometimes.
Been on the road since 6 this morning.
Yes. That's just on the Windows storage that we're monitoring. Like I said, we really don't want anyone to know we're there. We can talk a lot about more of the automation stuff that we do after the lab, but everything we do is really to prevent users from having any effect, in their day-to-day work. We don't want, a NetApp or an Isilon to go down because we're doing something, or a Windows server to lock up. Some people think of the classification a little bit like DLP, but we complement DLP. We want to replace it. Varonis uses the DLP solution as well, internally.
Good question.
Yeah, definitely.
Anybody else? All right, Ryan, the room is good. Oh, you got one?
Yeah, I was going, what's the top tool for attacking right now?
Good question.
Yeah, Ryan, what's the top tool for attacking right now? Because I don't know.
The top tool used for attacking, or to
Yeah.
attack?
What do we see in the on the wild? What do you see? Is it I know we just had that Qbot malware. What's the top threat?
The top threat, and I don't think it's necessarily a tool. The reason why I picked the insider threat scenario today, one of the biggest things that we're seeing out there is insiders, and it's not always intentionally malicious either. Sometimes this is just insiders who may not be as technical, or maybe not really realizing what they're doing, but taking data out of the network. Again, emailing things to themselves, saving it offline, taking it home, maybe a minute later. This is stuff that we really need to lock down. And a big issue that we see across a lot of organizations is a lack of understanding of where the critical assets are when it comes to the unstructured data. So not understanding where do you have files that contain social security numbers, or HIPAA data, or credit card numbers, or other PII or PCI compliant areas. So not understanding where that is, and then not being able to control when that data is leaving the network. A lot of times we're really good at locking down our databases, we're really good at locking down our endpoints, but when it comes to kind of that unstructured data that floats around there on our network side of things, there's not a ton of visibility. So I think that's something that we're seeing quite a bit of, and not always super malicious. These aren't APTs that are coming in and doing this. This is a lot of times just normal insiders taking data out of the network, which is still a huge vulnerability for us from an organization standpoint.
So it's more about being responsible with your network, what you're doing with your files and the device.
Definitely. And then also, maybe someone's leaving the company and they want to take, their data with them to the next company. Maybe there's a nation state that's paying someone for intellectual property. And so just, safeguarding the data from the inside, and it's stuff that, as Ryan mentioned, maybe they don't need a tool. Maybe they have access to it because of the, work they do, their department or something, and we just want to make sure that we're baselining their behavior and understanding what their day-to-day looks like, so when they do something anomalous, we're aware of it.
Yeah.
Yeah.
Exactly. And if you're going to boil it down to a tool, I guess, I would say just native software, right? Just normal use of Windows systems, normal use of our networks. It's really dangerous, which it's kind of hard to believe. A lot of times we're focusing on the Mimikatz and all these crazy APT techniques that are happening out there, but there really aren't that many APTs. Really, our biggest volume from a threat perspective is the normal attackers, the script kiddies, the normal insiders who are just doing normal things every single day. So,
I think you can go ahead.
cool. Awesome questions. And actually, I did hear part of one question I think about, could this also be a bit of an external threat as well if somebody were able to compromise an account and get onto the network? And absolutely, that's actually a point that I was going to bring up too. If somebody was able to get onto a network and compromise a workstation and compromise a set of credentials, they could definitely follow along this same attack story that we're about to do right here. So definitely keep that in the back of your heads too. But as we get into our attack, this is the first virtual machine that we'll be on today. This is desktop one. This is my pretty typical end user workstation. I'm logged in here as engineer, a typical technical insider. I always think it's important to talk about the backstory a little bit, right? Engineer definitely has a technical background. Engineer understands the concept of permissions, right? So engineer knows his normal domain user rights aren't going to give him access into the finance directory. And keep in mind, we eventually want to get into that finance directory. Whatever our motivation may be, we want to get some sort of this insider financial data that we can then take out of the network. If we want to game the stock market, maybe we're just trying to get some sort of intel on the inside. And again, this is applicable in a lot of different use cases. It may not necessarily be financial data, but that's what we're after here. Engineer also has a technical background. I think it's important to preface with that too. So we're going to use a couple different PowerShell scripts today. Everything that we're using is either open source and free and easily downloadable off of Google, or a couple PowerShell commands that we've thrown together into a nice little quick script that we can run just to make things go a little bit more smoothly. So that being said, let's get into our attack story here. So we're going to start our attack in the reconnaissance phase. We're not so much worried about that intrusion phase again. We're going to open up our Kerberos script. Now this is a PowerShell script that we've put together, a few different things that we've combined. And one of the first things that we're going to do is query for our SPN values. Now, I'm sure somebody out there familiar with the concept of the SPN, but for anybody who isn't, it stands for Service Principal Name. And this is an AD attribute that you can kind of think of as an alias between a service account and the service that that account is running. So every Windows environment is going to have SPNs. These are completely normal. We need to have SPNs every single day. A lot of times it's thought of as, if you're trying to figure out, well, where are my SPNs out there? Things like SQL instances, when you have a SQL server out there, on that SQL server, you're going to have SQL services that are running that instance. And each of those services has a service account running it. And each of those service accounts has an SPN value that points back to that unique SQL instance, that unique SQL service. And this allows us to do things like running those services on startup without running them as local system, and being able to access those services remotely without running them as local system. So we need this functionality every single day. But because of that, any normal domain user can actually query for our SPN values within the network. So using something like a simple setSPN.exe command within PowerShell, I can query for all my SPN values within the domain. So I can see all my service accounts out there that have these SPNs. I see the services that they're running. But not only that, I also want to see if I can request access to those services. Again, normal domain user functionality, I can request access to these services through their SPNs. But something to keep in mind when we request access to a service, we have to think about Kerberos authentication. So what I'm going to do here is request access to the services. And in doing so, I'm actually requesting a TGS.
Brian, pause you real quick. I'm sorry.
Can you expand your windows just a little bit?
Let's see. Oh, the actual, these?
Yeah. That'd be perfect.
Yeah, and I'll make this one.
Up your font size.
Yeah.
The resolution.
It might be a projector issue, but if you can somehow zoom in a little bit.
Let me see.
We might lose the focus anyway based on the projector, but
Yeah, I'm not sure it will let me get that much closer. Seems to be blocking me here, but I will just explain what I have right now. And then when we get into the side with Varonis, where we actually are reading things a little bit more closely, I'll make sure we can get bigger. That'll be easy to read. This is more of just kind of things are moving, and I'll explain it as we go. But you're going to see here this pop-up. So in requesting access to all of those services, I'm actually requesting a TGS. So if we think about Kerberos authentication, we have our TGTs, those ticket granting tickets, and our TGSs, those service tickets as well. So when I request access to the service, it's going to give me a TGS from the KDC. And that TGS is actually going to contain the password hash of the service account running that service within it. So what I've done here with a little bit of PowerShell magic is I've actually dumped and I've exported those TGSs or those service tickets, and I've saved them locally on my end user workstation here. Now keep in mind, right, all of those TGSs contain the password hashes of their respective service accounts running them within it. Now, as we think about our attack story, right, eventually I want to go ahead and try and compromise one of these service accounts. And what better way to do that than take one of these password hashes and potentially crack it offline? So now I have access to all of these password hashes within this here, but I don't need to go after all of these accounts, right? That's kind of a waste of time and a waste of my resources. I really just need to get one account that's going to give me the access that I need to get into the finance directory. So what I'll do next is an LDAP query. Again, normal domain user functionality. I'm going to use LDAP to say, well, which of those service accounts is a member of the domain admins group? Domain admins, that should get me into finance. That's all I need. And it comes back with 3 accounts. You're going to see 3 accounts here: backup service, IT admin, and proxy. Now, in theory, I can go after any of these 3 accounts, right? I know they're all going to give me the same access, but I want to be smart about it. I'm thinking backup service. That account's probably the right one for me. Backup service, if they're running daily or nightly backups, I'm guessing they're probably not changing the password too frequently on it. I'm hoping that's going to give me enough time to actually try and crack that password hash once I take it offline. And once I do, I'm also hoping that it'll give me enough time to actually use that set of credentials around the network. I'm also thinking if there's any sort of blocking or monitoring capabilities out there, something like a backup service account touching something like a data source or a file share out there, I'm hoping that's not going to set off too many warning bells. So I think that's the right account for me. And just wanted to see, it sounded like any questions out there so far?
So do we all understand, he goes out, he can see all these SDNs, he's identifying, downloading these tickets that have these password hashes in them. He's seeing that he has a backup service ticket. He's seeing the backup service is also an admin. So that's the account he wants to crack.
Okay.
No. He's just starting out. He's saying an engineer just because he says like someone like this, someone who just has enough technical knowledge to understand what LDAP is, to understand how to run a PowerShell script. Now you have someone that's, maybe an analyst somewhere, and they want to see if they can peek into the finance folder for your organization.
What is he doing to cover his tracks?
Well, so he's doing this query. So if you have something that can detect query, definitely, that's something we'll look at later with the threat models. And then as far as covering his tracks, he's trying to use an account that is not going to seem suspicious. So the backup service account, as you mentioned, this is an account that probably touches a ton of data on the network, might already be backing up the finance folder. People aren't going to think it's suspicious when it's going in and touching that folder. Also the fact that, as you mentioned too, the password's probably, but fortunately a lot of organizations don't have those implemented. Yes, typically they do run at night. So if you have something that's locking out an account to only run during certain hours, let's try that account during working time. But a lot of times, I mean, what if he's in Mongolia and he's trying to sign in and maybe like his, hacking hours are the same as the nighttime hours. I mean, we got to assume that maybe even the engineer, could be logging into the server as well.
Being presented, we are recording through Zoom, and for members of the chapter, we will the recording of everything that's being displayed on the screen. You'll be able to see it better. If you're a member of the chapter, it'll be in our members portal on our website.
To the point about covering his tracks, remember that to find an anomaly, somebody's got to be looking for it, and have a baseline. It's got to be looking for it. It's got to stick out. And for all you've said right now, that's not going to stick out. It's not going to.
Yeah, this is like both the SDN queries and LDAP queries. LDAP queries have all. If you have LDAP running and the application is using LDAP,
I work with a website. We have our authentication here, and our authentication kit goes out to an LDAP system that's off our network, that's managed by somebody else, and pulls back user information as well as other personal information back to the LDAP. So we have LDAP very all the time on the system.
No, definitely. And then also, I mean, there is stuff you can do, but a lot of times we see full-time employees trying to sift through logs, trying to figure out that something's suspicious here. If you're good with data, you could probably create some sort of rule or query to alert on this type of behavior. But once again, too, if you don't know what you're looking for to begin with, you might not have those in place.
Nothing he has done so far would have risen to the level of an alert.
LDAP very happy all the time. SPM very happy all the time.
Yeah.
If you're using, I guess it's okay. It's the same backup
I would agree. I would say that the majority aren't, but I mean, I agree that, yeah, this is stuff, if you're looking for it, you could definitely easily see the backup service running outside of its normal time. Can we start them up again? All right, go for it, Ryan.
All right, no worries. No, this is great. Questions, keep them coming. But we're going to continue on here with our attack. So I've decided I'm going to go after backup service, right? I'm just going to make a quick selection within my script here. And what's going to happen next is I'm actually going to take the password hash out of that service ticket, and I'm going to load it into John the Ripper. Hopefully you guys can see this one, nice and big font. For anybody out there who's not familiar with John the Ripper, it's a really common pen testing and hacker tool out there. It's free, it's open source, it's really easy to find online. Probably wouldn't do it on your corporate machines today, but really easy to get to. And what we're doing here is actually attempting to crack that password hash. So John the Ripper is pre-built with a list of clear text passwords. It's going to hash those passwords and compare the two hash values together. And when we get a match between those two hash values, that's when we know we have the clear text password. And you can see here we're averaging a little over, looks like 300,000 passwords per second. We're going to give it a few seconds here to see if we can crack that password hash. And then if we can, that'll actually give us that clear text password that we can use that set of compromised credentials. Now, you can see we've cracked the password hash. It took us about 37 seconds. It was pretty quick, but you can see it's also a very simple password that we're using out there. It's password1 with an @ sign and a 1 on the end, just in case you can't see it. So 9 characters with a special character and a number. You might be thinking to yourself, well, that's a really simple password, right? Password1 with an @ sign. But believe it or not, 9 characters with a special character and a number, that's really not too far outside the realm of typical domain password policy that we see with a lot of organizations today. So again, really important to make sure we have those long, complex passwords, really emphasis on the length, especially for these service accounts. And on top of that, especially those service accounts that also have those SPN values, because now you can see how accessible those password hashes are just by assigning that SPN value to it. So really important to monitor those accounts very closely. But now here with our attack, we've compromised our first account, backup service. We have our set of credentials using a backup service, password1 with an @ sign. And now we're going to move on to our next script here.
I'm sorry, Ryan, can I interrupt you once more?
Sure.
All right, I just want to mention that this was simple. But if you think about all the breaches that are out there, Marriott, Experian, they're collecting these passwords. Your passwords are out there, they're known. So they're building these dictionaries off these passwords, and then they can go rent virtual machines, Amazon Web Services, and they can run this with 50 servers with 16 cores each and be able to plow through that ticket. So just, like I said, we're simplifying it for time today, but it's very real.
It's also worth pointing out, and it's probably apparent, but that computing is obviously not done on their network or on anything that would generate a log. So catching somebody doing that is impossible. So if you're doing it on on their local laptop themselves doing the cracking, or they'll be doing it off of the network, so there's no logs on your network to catch that activity.
If you want to know whether or not your credentials are out there in the wild, go to Have I Been Phone? And then put your email and you'll find out.
Yeah, definitely. And something that these guys have is they have time. So if the backup service account, if the password's not going to be changed, maybe it takes them 25 days to figure out what the password is. But as long as they find the data at the end, that's they get their goal.
Ryan, back to you.
Awesome. Thanks, guys. So what I've done next is I've opened up this script that I'm calling File Crawler. Now, File Crawler, it's a pretty simple PowerShell script that we're going to use right here. You can think of it as kind of a big fancy Control F or a big fancy find function, right? If you have your PDFs or your Word docs out there and you hit Control F or you hit the find function, you're going to get that little pop-up. You type in your keywords, you type in your string, it'll index that document and tell you exactly where in that document that keyword or that string sits. Really common, we use it all the time. Now, we're going to be doing something very similar here, but we're going to be doing it at scale. So using PowerShell string search is a pretty simple concept there. We're actually going to index all the files found within a certain directory that we point this script at and try to identify any of those files that might contain any of the keywords that we type in here. So now I just need to type in some keywords. I'm running this script as that backup service. You'll see that right here. And again, keep in mind, backup service is a domain admin, right? So I've already pointed this PowerShell script at the finance directory in the background. I'm going to index all the files found within the finance directory. And now I just need to type in some keywords, some things that I might be looking for around the network. So if I'm an insider looking for some sort of financial information, maybe I'm looking to game the stock market a little bit, I might be looking for something like Q4, maybe I'm looking for quarterly earnings reports, maybe if I'm looking for things like bank account numbers or routing numbers, maybe social security numbers, credit card numbers, whatever the case may be, I'm going to hit OK here. It's going to start to index those files found within the finance directory. But I think it's really important to point out that this script is really applicable in a lot of different use cases, right? If I'm looking for maybe a tech organization, I'm trying to find some sort of insider proprietary information. I might have some sort of source code that I'm after, or maybe some sort of proprietary string that I know. I can index all these different files found within my file shares. Maybe if I'm working with a healthcare organization, right, and I want to steal some sort of PHI or HIPAA data, I might be looking for medical record numbers. I might be looking for different types of insider information for the patients themselves. Really easy to use and very applicable in a lot of different use cases. Now, the other important thing to recognize is this is a very simplified attack scenario that we're going through today. I found some data here very, very quickly, but in a real life environment, if this is a pen test scenario or if this is a real life attack scenario out there, I might be doing this for days or weeks at a time, right? That was a really good point that got brought up. It's all about time, right? How much time is on your side, time and motivation. So I might be doing this for days, pointing this at different directories, looking for different areas around the network, trying to identify different pieces of data out there, really trying to identify that sensitive data that as the attacker might be good for me, things that I want to take and get out of the network. So with that being said, I've identified, it looks like about 11 files here that contain some of those keywords. So if I'm looking at the file names, I'll just call them out because I know it's hard to see, but things like 2020 plan, so maybe some long-term financial planning, customers, full lists. So this might be my customer insider list in there. I see marketing plans, Q1 through Q4 2018. So maybe some of those quarterly earnings reports, if I'm trying to game the stock market a little bit, trying to beat that earnings release, financial reports, all really good data if I'm trying to find some of this insider financial information. Now, not only have I identified this data, I'm also going to download this data. You'll see it populate here within this temp files directory on my desktop. And I'm also going to zip this data up. So I'm going to zip that temp files up. I'm going to put a password on it. And the reason that I'm going to do that is I'm hoping that this is going to allow me to get this data outside of the network. Again, I'm not putting a password to try and protect this data that I'm in the process of stealing. But you can see I've just finished this script here, and we have this private.zip directory that showed up on my desktop here. Now this folder contains all those files that we found. It's zipped up, it's password protected. And now we're going to move on to our data exfiltration phase. So as we move on, just wanted to stop here to see if anybody had any questions on what we've seen so far.
Okay, and again, this is on an unprotected network. The question is, this is on an unprotected network, Ryan?
So by unprotected network, just wondering, what do you mean by that? So like not monitored at all, or like open to PowerShell scripts?
Right, so for instance, you've got access to what you're doing, you can personally identifiable information and protect the network unless you actually have the permission or the right to part of your role responsibility. Regardless of what you don't have access to that stuff.
Yeah, so we've taken the backup service account, and we're assuming the backup service account has access and is backing up sensitive information.
Yeah.
So we're just looking at files. So the backup service account goes out, it has access to all file shares. It can pull it back from okay. So you've already got that for you're inside the network, right? So it's not a matter of being protected or unprotected. You're already in. So you're already through the front door.
And you might be a little bit ahead of us too, because we're going to say like things that you should be monitoring at the end here and how to catch over them. But I mean, good question.
So, those files, this is those files that was put a password on it. It goes under the card on the directory section.
If you have some sort of DLP, there could be some sort of detection for encrypting data depending on the rules you have set up.
Oh, wow.
Yep. And a lot of companies, I mean, if you try to put something on a USB thumb drive, it's going to alert. There are definitely a lot of solutions out there to monitor the endpoint.
You're good, Ryan.
All right. And I heard a really good point being brought up about accessing the sensitive data and how to find it. Keep in mind, in the beginning, when we were doing that basic reconnaissance, we ran that LDAP query, and that allowed us to identify that that backup service account was a domain admin. So capturing that domain admin set of credentials gave me virtually unrestricted access to our data, right? Domain admins are typically going to have access to our finance directory located on our file share. So that's why I went after those domain admins first. And then once I compromised those credentials, that's when I came back and actually accessed the data there. So now we have our data compromised. We have our private.zip folder here. We're going to talk about our data exfiltration next. When we talk about data exfiltration, there are a lot of different ways that we can get data out of the network. In another scenario that we go through, we use a slightly more sophisticated technique. I'm not sure if anybody's heard of it before, but it's called DNS tunneling. It's a little bit more of a low and slow method. It's a little bit more APT-esque, I guess you could call it. Typically pretty successful because you're breaking documents down into individual bits and then sending those bits out through DNS requests, virtually tunneling them out through DNS queries, and then you rebuild that document outside of the network. So really cool way of getting it out, but it takes a long time. You have to do it document by document, a little bit more of a low and slow sophisticated technique. For something like an insider threat scenario, and this is something that we see all the time, I think sometimes the simplicity of it is kind of the elegance or the beauty behind this type of attack. We're going to do something here that we've probably all done at some point in our lives ourselves. Hopefully not to steal corporate data, obviously. But what I'm going to do next is just log into my personal Gmail account, scveronis@gmail.com, and I'm just going to send myself an email. And all I have to do with that email is attach my private.zip folder that I have here on my desktop. So I'll hit compose. We'll send this to Veronis SE, who just saw me log in as. I'll call it top secret so nobody knows to look within it besides me. I'll attach my files, attach this private.zip folder. And you know what? I don't even really have to hit send here. As soon as that attachment is uploaded and this draft is saved, that data is essentially exfiltrated out of the network, right? Because I can save that in my drafts. Maybe I'll hit send anyway. I can end my session here. Maybe I have a couple more hours of meeting to attend this afternoon as engineer. I have a couple more hours of work to get done this afternoon. Go on with my day. At the end of the day, I'll go home, boot up my personal machine, jump onto my tablet, jump into my iPad, go back onto my Gmail account, and I can download that data outside of the network. It's no longer controlled by my corporate constraints. It's left the network at that point. I can access those files and I can do whatever I want with it. And keep in mind, those files contain things like credit card numbers. They contain things like bank account numbers, routing numbers, whatever kind of sensitive data we were after. And it's very, very easy for us to get this data out of the network nowadays. Using these third-party applications, I had a great conversation the other day as well. Not only things like Gmail are very accessible in many organizations, but also things like social media, Facebook, LinkedIn, Twitter. They all have these various chat functionalities in them, and a lot of them you can even put attachments on as well. So you can use the same type of attack or the same sort of technique that you see here to upload some sort of attachment to your Facebook account or upload something to your Twitter or your LinkedIn profile. Go home at the end of the day and download that back out of the network. Again, you'll have that on your own personal machine. So this about wraps up the attack side of our demonstration today. I wanted to pause here one last time before we jump over to my Varonis server. You saw how we did some basic reconnaissance. We identified those service accounts with their SPNs. We identified which of those service accounts was the domain admin using an LDAP query. We compromised that domain admin account through its password hash. We cracked that password hash. Then we used those domain admin credentials to run a quick PowerShell script, some PowerShell string searches to identify some sensitive data found on my file share. Then we downloaded that data, saved it locally here, and then just exfiltrated it out of the network using a very simple third-party technique there. So I'll pause here one more time, and then we'll jump over to my Varonis server, and we'll take a look at what we have.
Any more questions? We'll make you wait.
I guess it varies on how sophisticated your company is. Like I've worked for hospitals and other high-level companies where you can't access Gmail, AOL,
Sure.
Yahoo, LinkedIn, Facebook, Snapchat because they know that. They know that those are simple ways you can get stuff out of a system. So at the hospital I worked at, no matter how the email went out, it is scanned by the system. And the system is designed to look for file types that are built into our EMR system. And if it sees that file type, it rejects it. The system drops the email immediately and sends it to the IT supervisor to run a security check to see who sent it. I guess it really just varies on how sophisticated. I would think most companies would have those sites blocked at this point. Most major companies,
And I can tell you as a security consultant, that is the exception, not the norm.
So you also have to consider that Gmail has corporate messaging. So Gmail is a service provider for messaging corporations. So there are companies that
No, Gmail,
Gmail is
Commonwealth of Virginia.
Microsoft G Suite itself is not like G Suite.
Yeah, Commonwealth of Virginia uses Gmail throughout.
I guess if you use that, that's fine. But like most, like I say, work for people who have sensitive data like that, and they're, you would think if you're on the stock market or something. I would think I'm new to the whole cybersecurity side of it, but I've worked in IT support and other places, and I've seen what.
No, I think you and the gentleman
a lot of
behind
companies I've
you,
worked with do.
yeah, you guys have tools. A lot of companies don't have tools.
You're not like we shut people down from looking at cars on the web. Like we shut all outside. You didn't have a reason to be on the internet looking at a certain item. You didn't have access to it. It was blocked. Done.
For a lot of people, I mean, even people in this room, I mean, you understand it's hard to get budget. You might be the biggest proponent of it. You might be able to show them this attack lab, and they're still going to tell you, well, I don't have it in my budget.
I would agree.
Yeah. Because of what security they have. You're talking about a hospital. You're talking about one tactic.
I mean, one of the things we do is we install our software and do risk assessments for companies for free. Now, obviously, it's not altruistic. We're hoping to make a savings. But at the same time, you'd be surprised how many companies you probably use on a weekly or monthly basis that don't have anything in place, that don't know where their sensitive data is. Higher education, local government, and these are people that don't have budgets or don't care. Brandon and I talked about this recently. It's almost like a lot of people too, what happens to Marriott when they have a breach? Are you not going to a Marriott hotel next week? I'm still staying out. Yeah, it's,
Yeah. You can have my password, just don't take my pass, right?
yeah, no, no.
So, do you guys have a tool that will go out and look for data types?
Yeah, so we use Oracle outside in, and we can go out and we scan all the files, and we have rules that are built, and they're built off regular expression patterns combined with dictionaries, and you guys sound like you might already have some tools like this. And we can identify where the PCI data is, where the HIPAA data is, where the Social Security numbers, we do GDPR, CCPA, all that sort of stuff. And we're not the only people that do it. We'd like to think we're the best at it.
I'd also add that 2 points. One was kind of touched on, but when you add encryption to the mix, depending on the type of encryption that you're using and whether or not your company has the ability to decrypt and do deep packet inspection, et cetera, not everybody does that. Not everybody can afford it. As soon as you throw encryption into the mix, it's a blinder, right? So you can't see that data. If I'm successful with a domain admin account of locating that data and then accessing that data and then eventually getting it to a place that I control, again, being on your network perhaps, seeing it off once I've encrypted it, we saw a very trivial way with Gmail, but he also talked about DNS tunneling. So there are more sophisticated ways that even really good tools. I mean, ICMP, if you want to just blast out a small ICMP packet, nobody blocks outbound ICMP. Most of the time they'll block inbound. But if you're just popping it out, a few bits, a few bytes at a time through ICMP traffic, and it's encrypted, there are more sophisticated ways. I think the intent is to kind of show a 13-year-old, which was mentioned earlier. These are things 13-year-olds can do. They might not get caught. The company might even catch them and just shove them and then they're done. Or they might pursue it and now you're in trouble.
Yeah, understood. But from a vendor perspective, right? And that's the thing to it. And I know you also know that it's not that. You also know that they're restricted control. I control network. So from a scenario, it becomes more just a sales opportunity to shut down, right?
Yeah, totally. And we're not here to dupe anyone into thinking that. And I think some of the questions you asked earlier, you're going to see the explanations as we go into the Varonis dashboard, and you'll see how we would caught certain things along the way. To your point.
And you may be doing some of this.
Yeah. And just before we jump into this and give this back to Ryan, just a show of hands, has anyone worked with Varonis in the past or works with it now? Anyone at all? Okay, so this is going to be new to everyone. Okay. Ryan, you're back.
Okay, cool. So now we've jumped onto my Varonis server. I switched VMs here. So we're on our Varonis data security platform. This is our web dashboard. We have a couple different interfaces that we have here on the Varonis side. We're really going to be on the web dashboard today. And there are a couple different dashboards within this that I'll show you. We're going to spend most of our time within the alert side with our investigation and the forensics, but I do like to touch on some of these other resource dashboards too. When we think about Varonis as a data security platform and really security in general, I like to think about it in kind of two different lenses. We have both the proactive side and the reactive side. Reactive side being all the great monitoring and the analytics and the alerting capabilities that we all have every single day. But I think the proactive is really important as well. Again, understanding where do we have areas of inherent risk around our data? Where do we have areas of inherent risk around our domain? Those vulnerabilities around our networks. Again, vulnerability management is huge, but a lot of people don't always think about it from a data perspective too. Understanding things like sensitive files with open access, understanding where this sensitive data might be overexposed to way too many people in your organization. How many people out there have heard of the Everyone Group before, right? Everybody's seen it out there, but how do we know where it's affecting our users? Where do we know where it's affecting our sensitive data as well, right? Where do we have these files that contain those social security numbers or those credit card numbers that are open to everybody in the entire organization? This is a huge problem, and it's a huge vulnerability that we see in a lot of organizations today. So we've built out these proactive dashboards that really highlight these areas of inherent risk for you, not just on the data side, but also on the domain side. So we have about 25 or so key risk indicators here showing you things like admin accounts with SPN, right? I always like to highlight this one because this is how we compromise that backup service account. Of course, every organization is going to have some admin accounts. We need to have privileged users out there. And every organization is going to have SPNs. We need to have those service accounts with SPN values in order to do a lot of the things that we do. But it's really important for us to understand where do those two overlap, just due to the inherent risk behind that, the accessibility of those password hashes, making sure we're securing those accounts properly. So again, we've built out these great key risk indicators to really show you the proactive side of your security posture. Now let's jump back into our alerting component. This is going to show you how we can start to pick up that backup service account. Right? Really here, I want to figure out how do I identify that abnormality or that pattern of abnormal behavior that we're seeing from the backup service account, that compromised user out there. So just a quick overview. At the top, we have alerts over time. So number of alerts per day, color-coded by severity. This is a pretty fresh lab that I spun up this morning, so we don't have a lot of activity besides what I've just done. Top alerted users, top alerted devices, top alerted threat models. So all the threat models that you'll see here come out of the box. Top alerted assets, so the various resources that we're monitoring, those data stores, which might be under attack. To the right, we have alerts with geolocation information. So we won't do a whole lot on this today, but we do have functionality around it. So when we're pulling in context from things like Office 365 or VPN or other data stores that contain external IP addresses, part of our normalization and the enrichment process when we create events is to take those external IPs and assign a geolocation to them. And this allows us to do some really cool things around alerting, like abnormal geolocations for a particular user, abnormal geolocations for the organization, things like geo-hopping, where you have a user logged in from 2 different places at the same time in the world. Really cool stuff to take a look at. And then down here at the bottom, we have our kill chain analysis. Again, that Varonis cyber kill chain that I brought up in the beginning, all of our threat models align to the various stages of this kill chain. So as we have alerts triggering, you're going to see these different stages light up. Just a quick graph down at the bottom. Now, what I'll do next is jump into our analytics view. I just want to make sure, can everybody out there
Sorry,
see
Brian, 1 second. Question.
Sure.
So you mentioning your threat models, are you building those yourself within Varonis based on machine learning, what you see on these networks, or are you using industry threat models?
Nope, they're all built in-house. I think we have 150 something of them, and they span from threshold type stuff that, you know, someone's been added to an admin group, to some of the ones we'll see here, like, you know, backup service, access to the internet for the first time. And all of them too, what we're doing is, and this is where I think we differentiate ourselves, we do have user identity behavior analytics. So we have really powerful machine learning, creating what we call peacetime profiles, so what normal behavior looks like for a user. So if it's a backup service running during the day, that's not normal, we're going to throw an alert on that. Backup service, your first time access from a PC, you know, why is the backup service coming in from the engineer's PC, stuff like that. So we know where the backup service normally runs, the data it normally touches. Maybe Dan's leaving the company, Dan's accessing data that Dan's never accessed before because he wants to take it with him. So in the 30, 60 days that we've been tracking you, if you haven't accessed it, why are you accessing it all of a sudden? We're going to throw it over.
Yeah, go ahead.
Is this product comparable to like a logarithm or Splunk, or would it augment or complement?
Yeah, good question. So we are not a SIM. We do have, for Splunk, for example, we have a Splunk app for Varonis. Logarithm, same thing. There's full integration. So you can get your Varonis alert sent through your SIM, and they'll come up in your SIM dashboard. So all the major SIM players, QRadar, Logarithm, Splunk, anything that you guys may have.
Yeah, we can export everything through Syslog, so basically we play with everything. One of the big things too, though, is people say, well, I have a SIM already. I've got this logic built in SIM. Why do I need Varonis? One of the big things is, once again, going back to the UBA, most SIMs don't have any behavior analytics going on. A lot of times the SIM also is monitoring the perimeter. For me, you know, I know large companies that have 10 full-time employees within a SIM, and they just run more hay on top of the stack to find the view. So it's a compliment, definitely. Do we have any others? All right, Ryan, I think, go ahead.
All right, perfect. So let's take a look at some of these alerts. And can everybody out there see the text on the screen? I just want to make sure. I zoomed in quite a bit, so hopefully we can see it now.
I would still read it out as you go.
Perfect. Okay, I will. So we'll start with our first alert here, just looking at some of these threat model names, we're going to be able to piece this storyline of this compromised backup service account together. So our first alert here is abnormal service behavior, service account logged onto a personal device for the first time. Now, a bit of a mouthful with this threat model name, but there's a ton of context that comes out of this out of the box. So anytime we see abnormal service behavior, we know that this is a service account specific threat model. This is something that we do every single day as part of our behavioral analytics. We're pulling in all of your user accounts and automatically classifying them as admin accounts, service accounts, executive accounts, and just normal users. And this allows us to design really granular, high fidelity threat models around each of these account classifications. Because if you think about these different account classifications from a behavioral perspective, something like a service account doesn't typically interact with your data and it doesn't typically interact with your network the same way that a normal user or an admin might. So it's not really fair to lump them into the same buckets from a threat modeling standpoint. And this is what allows us to have those really granular but low volume. I always put the emphasis on the low volume, right? Because we don't want to throw alert fatigue at you. We want to make sure you're getting a manageable volume of alerts coming through on a daily basis. And those alerts that have a very high fidelity or an actionable result out of them. So here we see it's a service account logging onto a personal device for the first time. This is coming from our directory services monitoring. So we're pulling this from our AD audit trail. We can see this one is triggered by backup service on desktop 1. Now, of course, we know we were backup service, right? This was the account that we compromised. But just by reading this threat model name, it's kind of strange, right? Why do we have a service account logging onto another user's machine? We see that it's this desktop 1 machine, and as we want to drive a little bit deeper, we can click on this alert details button. Now, this will bring up our context page. Now, I think this is a really great pane for an investigation, especially for all the analysts out there. It's going to give you a lot of this context up front, and it's going to make your lives a whole lot easier as you're starting to triage these alerts. Really, our goal is to give you as much beneficial context as we can before you really have to dive too far into it. So you'll see a quick summary at the top, backup service logged onto a personal device for the first time. We have our threat model name. We see our risk assessment insights. So the user that triggered the alert was backup service. We see that nothing changed within this account in Active Directory in the past 7 days. That's always good to know, right? Because if I'm seeing a deviation in behavior from a service account, I might expect to see something change within Active Directory prior to that, right? Maybe a group membership change, AD property change, something changed to trigger this change in behavior. But I don't see that there, so it's kind of interesting. I also don't have this account on a watch list, so I haven't seen a lot of bad behavior before, but maybe I want to start adding this user to a watch list. And this user has also triggered 4 other alerts in the past week. So that's a bit interesting. I'm starting to see a pattern here. As I come down below, I see that I have my devices in sight. So the device that was being used during this was desktop 1. And I see desktop 1 typically belongs to engineer. Again, this is another really key piece to our user behavioral profiles. We call it user device affinity. We're automatically learning which user typically uses which device, and we're going to assign or pair those users and those devices together. So in a case like this, we see that desktop 1 is typically belong to engineer. And remember, we were engineer. We were on engineer's normal device out there. And now this is a pretty big red flag to us because we have 4 alerts coming from this, and now we have a service account on somebody else's machine. We don't see that too often. We don't often see end users sharing workstations, and we don't typically see service accounts logging on interactively to another end user's workstation as well.
Can I pause you real quick?
Sure.
Hey, Ryan, are you taking that data from your CMDB, or are you simply capturing the log-on activity? So I'm wondering how you tie the workstation to the user.
Great question. So that is coming from the activity. That's part of the machine learning and the user behavioral profile that happens in the background. So we're capturing, sorry.
I was going to say, you could take that functionality out and sell it to somebody for their CMDB and make a bundle.
We want to keep it in here, but that is an idea. But yeah, we're capturing logon events every single day. We're capturing all the access activity across all the different data stores. We know it's normal for every user every single day. We're going to baseline that normal behavioral profile. We know engineer logs into desktop 1 every single morning. Yep.
No, this is all, there's no agents on endpoints, so this is all coming from the directory services information that we're seeing.
Oh, yeah.
We can resolve the host names several different ways, whether it's, directly to the machine or DNS lookup or everything.
Couple questions, Ryan. Hold on a second.
Sure.
Go ahead.
So if you're seeing offensive activity like spying have any proactive action that could trigger, say, this definitely unsolved something?
Yeah, no, that's a great question. You're throwing me softballs there. All of the alerts can be sent via email, they can send via syslog, and we can also activate PowerShell scripts. So something like ransomware. So we see this all the time. We set up, Ryan actually does this for customers every day. We set up these PowerShell scripts that if we see a user's encrypting file, something that looks like it's automated, especially, we can go out, shut down the account, shut down the computer, whatever PowerShell is capable of doing around that user. And then also the important thing here too is that we're not using definitions or endpoint protection. Are you trying to catch this ransomware? We're actually looking at the data, saying this data is acting abnormal.
On the same thing that she's talking about, what if that employee is actually doing something work-related that wants to give information to protect company information?
We can make exceptions if we need to. So we can scope everything. Everything's very, very configurable. Now, if they're doing something and they do it on a regular basis and we made an exception and then they want to do something malicious, you might have found a loophole there. But we want to look for the automation around there as well. I think the only time I've seen that in the past year is there was a college that someone was running some sort of compiler, and it was in a known encryption type that set off one of the ransomwares. But I typically don't see someone encrypting files that fast across a large organization. Yep, go ahead. Sorry. What was that? Yeah, he was just saying that this belongs to the engineer. We've assigned this device. We say that we see engineer log into this device every day.
Okay, go back. Okay. Labeled as a personal device, so I'm guessing that means.
Oh, that's saying that the backup service, we've classified that as a service account. We don't expect a service account to log on to an end user PC. Personal. Or device. Personal. Yeah. Ryan, can you define personal device in the threat model for us?
Sure. So,
yep. So the question is that personal device is typically defined as a personal device that's not owned by the company. So are we just defining personal device here as an asset that's used primarily by one user, or?
exactly. So it is the device that we have seen that user log into most often. And it's not necessarily one device. You can have multiple personal devices. So it can be owned by the organization. It can also be an outside device as well. We're just looking purely at the logon events and the actual log data that we're capturing, and then building into that profile which user is using each device most often and if any, each day. And then pairing those two together, saying, hey, we typically see engineer logging into desktop 1 every single morning. We're going to say this is most likely engineer's personal machine within the organization or within the environment that we're looking at.
So will this also integrate with like the mobile device management platform?
We have APIs. I would have to find out what platform exactly to know what we.
Yeah, what did you have in mind?
Android. So I say mobile device management. So have you heard of Microsoft Intune?
But Ryan, do we interface with Microsoft Intune?
Intune, I believe we may be able to put that together. We should probably take that one back and get a full response on it. So we do have a lot of API integration there around the reporting API, and that may be how we would pull that one in together. But I'd want to get an answer for sure from our product management on how that one would go together. I haven't built that one personally, to be honest.
Yeah, because your word personal is just throwing me off. Personal device. Personal device is just operating line stuff. It's a corporate network. I got to do that. Otherwise, I got personal device. Network already. I get that's what I'm saying.
No. I mean, I agree how that can be confusing.
Okay.
Yeah, go ahead.
So let's say, well, we just reached in, let's say you see who's done it, you wish to see it, didn't want it. But, oh, well, never mind, because it's quoting, or it's quoting now. I'm saying it's like, if you bring in a personal device from outside, how do you track that device location from that software?
Not physical location per se, but just, I mean, someone did bring in a literal personal device and they logged onto the network for the first time, it would set off one of our threat models and it would say, first time log on from this device. We've never seen this user use this device before. This is something peculiar or anomalous.
Would you then be able to tell by maybe norms who that user is if it's someone that's had access to the system before?
It's going to track, it's going to correlate those things. So it's going to correlate that someone logged on using a device. So we're going to get an account with it. We're going to get the IP, device name, and then at that point, as far as trying to identify where it physically is, would be,
That's not where, but the individual. User behavior.
I don't believe that you can do that.
I guess maybe I'm not fully understanding the question. I mean, we're going to see, you're saying if someone does it all the time?
Right, no. Oh, well, I'm saying.
Behavior analytics.
Behavior analytics. Will you be able to tell them that, let's say, X have been logging onto the system using different devices. Now he's logging on to the system using brand new devices he's never used before. Will you be able to use analytics to identify that individual? That's what I'm saying.
I don't know that we're as concerned about the device, and we're on the data layer more or less. So we're following who's touching the data, how the data is being interacted with. So if we see actions being taken against the data, that's more what was going to trigger our set of alerts.
Okay, but that's what you got on the screen right now.
Right.
Okay.
Yeah, I understand that there's some ambiguousness about the personal device part, but for the sake of time and getting through this whole presentation, can we table that just for a little bit and come back to you? Is that fair?
Yeah.
Okay. All right, Ryan, can you jump back in?
Sure, sounds good. So last insight here that we're looking at is the typical working hours. Again, another really key piece to that user behavior profile, understanding what typical time frame is this user, is this account typically performing activity. And so we see this occurring at 10:48 p.m. This was about a half hour ago. I'm running this actually out of one of our Europe tenants, so it's a little bit ahead of us here, but this is outside of the typical working hours for backup service. Again, based off of the activity that we've seen in the past, we've built out that baseline profile, and we're saying this is a deviation of that behavior, another red flag to us, right? This is something abnormal happening out there. Now, once we've gone through these insights, and if we want to really get down to the nitty-gritty detail, we can go to our next steps and click on our alerted events, and this will actually give us the series of events or the singular event that triggered the alert. So here we're going to see that account authentication, or we've broken it down, if it's a Kerberos authentication, into TGTs and TGSs. But we see our account authentication here. We see who did it, what time it happened. Of course, it's backup service, that it was authenticated using Kerberos, and we can validate the device that it was using at the time. So backup service authenticated using Kerberos coming from desktop 1. That was that abnormal logon that we just saw here. Now, as I'm going through this investigation, I'm thinking to myself, why do I have a service account logging onto engineer's machine, right? Desktop 1, it's kind of weird. But we'll continue on with the next few alerts, and we're going to start to build out this storyline a little bit more. So not only do we have that atypical logon, but we start to follow that up with some atypical access to some data as well. Again, these two alerts, we'll look at them together: abnormal service behavior, access to atypical files, and abnormal service behavior, access to atypical folders containing GDPR data. Again, both service account specific threat models because of the abnormal service behavior, but here we're seeing that data access, those file open events, and this service account is touching data that we haven't seen it touch in the past. In this case, we're going to see that this one is also triggered by backup service on desktop 1. And we'll continue on here. I'd probably want to dive a little bit deeper into my GDPR alert. So again, a really key piece to that analytics profile that we're doing, understanding where the sensitive data is. The sensitive data scan runs in the background all the time. In this case, not only is the service account interacting with data in an abnormal fashion, but we know some of those folders contain GDPR data. And it's not just GDPR centric, that's what we've used here for the sake of our presentation. This could also be PCI, HIPAA, GLBA, whatever the case may be, in understanding where that sensitive data is. Now we'll jump into our alerted events again. We'll get our context page here in a second, and we're going to start to see a snapshot around which data might be impacted. We start to see this finance folder had been opened by this backup service account. Again, we have a risk assessment insights here, backup service. We know this account wasn't changed in the past 7 days, not on a watch list, but I probably should have added it to the watch list by now. We see triggered 4 alerts in the past week. We know the activity is still coming from desktop 1, which is engineer's machine based off of that behavioral profile. We see a data insight now. So 11 objects were touched. 9 of those 11 objects are classified as sensitive based off of that data classification scan. And this is also the first time that we've seen this backup service account touch the C drive in the past 90 days. Again, another abnormality. About 2 minutes after that abnormal interactive logon, still outside of those typical working hours. And what I'd want to do here is jump down to my alerted events again. Now, I think this is probably one of the most critical pieces to our investigation. Having a file level audit trail is so helpful for us as we're going through our incident response plans and so important for us as we're going through these forensic investigations. Being able to actually understand which data is impacted is so critical as we start to escalate this potential security incident up the chain, right? Because this is where the tough people are going to come to us and start asking us those really hard questions. This is where the legal team might come to us and say, hey, do we potentially have a breach notification on our hands? Do we have to potentially let our employees know that their data has been impacted? Do we have to potentially let our vendors know that their data has been impacted? Maybe even worse, do we even have to let our customers know that their data has been impacted? Without having a file level audit trail and understanding exactly which files were opened by which user, from which device, at which time, very, very hard to answer those questions. So we see our file open events here. We see it's being done by backup service. We see where the data is located by path. We see the object name, that file name here, whether or not it's sensitive based off of that data classification scan. And of course, we can always validate it with the device that we see this coming from desktop 1, that same machine where we just saw that strange interactive logon for this service account. Now, any questions on this so far? I think this is really the first time we've touched on the file or the data audit trail here.
I think we're good.
All right. Awesome. So let's jump back to our last day. We have 2 more alerts to take a look at. I know I want to be time conscious here, so we'll wrap up pretty shortly here. But our last 2 alerts are coming from our perimeter monitoring. Again, we started with our directory services. We talked about the file server activity. Now we're looking at the perimeter. Both of these coming from our proxy monitoring. So we see this one here, abnormal service behavior, first time access to the internet. Again, we know this is service account specific. Maybe a normal user accessing the internet for the first time, not so strange, maybe not a high severity alert. Maybe I want to know about it, but I don't really need to know about it right away. The service account accessing the internet for the first time, that's a bit weird, right? We don't see that too often, especially the fact that it's that same backup service account following those abnormal data touches, following that abnormal logon to that personal device. And then we follow that up with an unusual amount of data being uploaded to email websites. Now it looks like we potentially have some sort of data exfiltration on our hands. If we scroll to the right, we could validate that, yes, this is backup service. Yes, this is on that same machine. And now we'll take a closer look at that data upload as well. So here we can see that backup service uploaded over 17 megs of data to mail.google.com, or as we know it, Gmail. Of course, this is a pretty big spike in this user's behavior. This is the first time this service account's ever touched the internet, right? We've never seen this behavior before. This is a big deviation. And now not only that, but it's also taking this data potentially outside of the network. We have our risk assessment insights below. We have our backup service account, desktop 1 belonging to engineer, still outside of those typical working hours. And before we get down to that final event level, just something that I wanted to touch on quickly is this new playbook functionality that we've come out with. So we're building these pre-built playbooks for all of our predefined threat models that are going to be built right into the web dashboard here. They're going to give you some background on the threat model, some reasons and why it might have triggered, really some good information on what we're designing the threat model for and how we're trying to pick things up. And this is going to be a great way to start those investigations in case this is the first time you're ever seeing one of these alerts before. Maybe it's the first time you're ever seeing an abnormal upload through something like an email website and you don't know what to do right away. These are going to give you some really good questions to start asking yourself so that you can start to actually make educated decisions right away. And really long term for us is to start having custom playbooks and custom incident response plans built right into this. Now lastly, one more time, we'll get down to that event level detail. We'll see our web proxy transaction here. We'll see whether or not it looks like it was successful. We'll see where it was going, what time it happened, which user did it. You can see it's going to mail.google.com over port 443. And one last time, we'll validate that it's coming from desktop 1. Now from here, we've really started to piece this storyline back together. Right? We have 5 alerts that triggered. What I'd probably want to do next is come back and pull all of my related events into a single table, really start to build out this timeline here. Might zoom out a little bit if I'm on my own screen, but you'll see all of the events in a single pane of glass. We have our full forensic investigation here. We can export this out to CSV. And now as we're continuing with our incident response plans, we actually have data to back it up. Again, we have those file open events. We know exactly which data is impacted, who it might affect, whether or not it's sensitive, and who did it as well. So this about wraps up the investigation side of our presentation today. I know we had a lot of questions so far, which is really awesome. I wanted to save maybe the last 5 to 10 minutes here for some more questions. And I know we're getting close to the end of the session as well, so I also want to be time conscious and make sure we get to the next piece as well.
Ivan, how much time can we take for questions?
5 to 10 minutes.
Any questions? Yeah, back of the room.
So does this have a delay in the alert, or does it is there a time frame that it will wait before it pops up the alert for calculate everything, or does it see the alert as the access is happening?
Yeah, that's a great question. The collector itself is going to be processing the alert. It'll be sending the email, it'll be writing the PowerShell script. So as soon as it collects the event, which is maybe 15, 30 seconds behind the time it actually happens, it'll be able to send off the alert in the PowerShell command. As far as populating the dashboard, there is maybe a 15-minute delay. We have jobs that run in the background that collect and publish these things. So you wouldn't be able to investigate immediately, but hopefully you would have something in place. Like I said, if it was a very...
If you get an alert from the email, then would that have information where you could do a quick look and narrow it down and so it's not waiting for it to pop up on the dashboard?
Yes.
Yeah. Yep.
So all the insights that you're collecting and you're presenting the timeline on the dashboard, is there any way you could say the likelihood that this is what you say and do it patient zero?
As far as patient zero, I guess, I mean, could you give me more of a situation? Is it a ransomware situation? Is it what would patient zero be here? I think it would probably require some investigation. I don't think that we would be able to automate that for you, at least not today. And I wanted to go back to what you were asking earlier. I think that, okay, and let me build this scenario. So someone's accessing the network or data with a different device every day as part of their job. Is that what the question was?
No, that's not different device every part of the job. Let's say they have access. So they're inside, they have access. But now they've decided that they want to be rude, so they want to be bad. So they're brought their personal computer in, and now they're going to an attack. They're going to steal whatever they can. They're going to go on and log in. So you can tell that. Pick up the fact of the farm device. They already identified that they can do that, but will you be able to? Because I keep hearing them say, "Who done it? Who done it? Who done it?" That who, but you're not going to be able to tell who in this case because all you can tell is, I'm just assuming you can just tell the foreign device, but you're not going to be able to tell who the user is. So the question was, are you able to use user analytics to figure out who that individual is?
Are you referring to the individual themselves?
That person. That's it, exactly.
You can use the tools to identify the user account. You can use, correct me if I'm wrong, you can use a tool to identify the device. You can use a tool to identify a number of things, but the individual themselves.
Yeah, if I'm using your account on your device, unless I'm accessing data you don't normally access, they won't be able to tell. If I'm using your account on a new laptop to set off an alert, they're going to think you're the person.
That's what I'm.
Yeah.
That's what I was.
Yeah.
That's what I was driving
So
at.
I think we see the same thing with like trucking companies that use like in a warehouse there's just a kiosk. Maybe they all log their hours from the same kiosk without individual logins, something like that, you would be able to tell if person 1, 2, or 3 clicked on something. Is that what you're saying?
Well, in a way, but again, I'm just saying.
I think I get what you're saying.
Yeah,
The only way I think we could do that is if we activated the webcam on the device and took a picture of the person.
Which just goes back to the point being that the more you can reduce the overall risk, right? The more you can lock down permissions, make sure only the right people have access to the right information. It narrows down that focus from the beginning. But yeah.
I was saying maybe like a log behavior, like you said, this type of behavior, similar to something Joe or John or David would be doing. That's what I'm getting at.
We're not there. I don't know if that's even a direction we're going. But I totally get what you're saying. You could say, it's almost like a criminal investigation, like this fits someone's profile. We don't know who committed the murder, but they used the knife, they killed this person, they drove this car. Yeah, exactly. Sounds like, Joe did it.
In the library with the knife.
Exactly.
I'm asking too much.
Go ahead. Sorry? Yeah, so this is all through the Varonis platform. You're looking at just the alert dashboard. Yeah, Varonis is the company. Yeah, you can't really see it in the top left there.
So I see an export option there. I think that exports all of the collected alerts and everything.
Yeah.
Or we're still including the file.
It won't actually report the files, just the file locations. And even in everything we do,
Identify what files.
yes,
Correct.
we don't keep any of this data. We don't store the files. We don't index the data within our platform. We have a pointer that says X, Y, and Z is located here. And if it's something where you want to open it up and find out what actually was in that file, we'll reanalyze it as you go out and search it. So we don't want to store any of sensitive data for our customers.
If you want to see what files they sent out, you got to go to the directory that is provided there.
Yes. And we have that as part of our tool too, different interface that a lot of access management and systems reports can be run out of on the back end, where all the metadata is kind of pulled in. This is more of a, as we talked about, high level dashboard for risk indicators in Active Directory to help you harden Active Directory, overall security posture, so you can see how many sensitive files and open access you have out there across all your storage put together. And then also for investigations, to be able to dig down and see activity very quickly.
So 2 questions, assuming that answers the question. Okay. Is this a on-prem or cloud-based solution?
We are totally on-prem, your hardware, our software, 3 to 4 VMs, typically 50 servers per collector, which is one of those VMs. If you have different geographical locations, we would maybe recommend setting up a separate collector in each geographical location. We do have a cloud service that's in beta right now, but it's not something that we're installing.
The second question was kind of going back to this specific scenario. Well, actually, the scenario that Chris brought up. While you can't necessarily, with any tool that I'm aware of, pinpoint the person behind the keyboard, if you see that rogue device that comes onto the network and it's not in something that a known good directory, using the PowerShell integration for calls, you could potentially shun that device with PowerShell and say, don't let it do anything.
Yeah.
So I mean, while you may not be able to pinpoint to a person, there's possibly a way that you could prevent them from doing much harm. If you're aware that they've made connections.
I'm not aware now.
You buy this super duper product. I don't work for Varonis.
Yeah, no, I mean, we know, typically you have to supply an admin password and username to join a device to a network. No, I love it. If they were all easy questions, it wouldn't be any fun. I learned stuff here. I mean, this is, an easy place to learn something, whereas if I'm in front of a customer and trying to close a deal, I don't want to be learning then. So, no, I love it.
Anything else? Yeah, go ahead.
I was going to just possibly use when that comes about for in the future.
I have no idea.
Yeah.
Yeah, where's APEX?
Let me shake my magic 8-ball. Right?
I think this guy built an Apple computer back here.
Cloud computing is on the verge of becoming the next big thing. Nobody knows what direction that's going to go.
Not in our lifetime, then.
Well, yeah, in our lifetime.
You're like this.
Yes.
This is something we have to try 30 years. My house is I see 5 miles that things are right, I want to stop. Do I have to get in there to use PowerShell to block that machine? Or can I go in there and something easy, figure out another way to IPFS, not that person out, and wait until they call me because they can't access that one. And then go there and see what's going on.
Sure.
Does that have that?
So well, that goes back to the automation behind the alerts. We can automate it. If you don't have the automation set up, it would be a manual process. You would have to see something pop up on that dashboard that catches your eye. You would have to look at it and say this person's doing something funky. And then whatever steps, whether it's a PowerShell script, whether it's walking down the hall.
Well, they say configuration, when we set it up, and I told them to say, like, from your dashboard, from your team.
You would have to automate it. There's not going to be a button per se. There's not like a single click that's to shut it off.
I got a question since you asked that. Now, you said the system automatically sends emails. Can you respond to that email with stop everything type response? I don't know.
No,
Right?
yeah, the email's going to be a no reply. There's not like an incoming mail server to process anything.
Right, there you go.
Go in with the PowerShell script, we can go in with the.
Well, it sounds like this was interesting. We got a lot of good questions. Probably, Ryan, this is probably one of the sessions you've done with getting the most questions, I would assume.
Yeah.
But we're gonna wrap it up unless there's anything else. We'll end our presentation here.
Thank
Thanks, Ryan.
Thank you very much. Gentlemen, on behalf of the chapter, a challenge coin for each of you.